You know, if you're in pretty much any technical field, I'm talking engineering, data science, you name it, you definitely know the name MATLAB. It just feels like it's always been there. But have you ever wondered how this one tool became so fundamental to, well, how we build the modern world? That's the story we're going to unravel today.
So the very first clue is right there in the name itself. MATLAB is just short for Matrix Laboratory. And honestly, once you get that, everything else kind of starts to click into place. At its absolute core, it is all about matrices, arrays, and the super powerful math that makes them work.
But you know, that simple name hides a really fascinating evolution. How in the world does a matrix laboratory, a tool that sounds like it's just for math nerds, become the engine behind designing space systems, building complex AI, and even programming robots? That's the big question we're going to answer.
To really understand MATLAB, we have to go back to the very beginning. And it didn't start in some big corporate R&D lab. Nope, it started as a side project, a hobby for one professor who just had a very specific problem he wanted to solve.
This quote from its creator, Cleve Moeller, really says it all. Back in the 60s and 70s, he was a math professor, and he saw his students struggling. He didn't set out to build a business or change the world. He just wanted a simple little tool to help them learn. And he actually based the very first version of MATLAB on his own PhD thesis.
What's amazing is that for about its first decade, MATLAB wasn't a product at all. The first version, which had just 71 functions, was literally given away for free at universities that Moeller visited. It spread through the academic world purely by word of mouth, just because it was so darn useful.
And this slide just brilliantly illustrates its whole original purpose. See, before MATLAB, if you wanted to do any serious matrix calculations, you had to wrestle with a really complex, low-level language like Fortran. Moeller wanted to just get rid of that barrier so his students could focus on the math, not the programming. That was it, a simple, powerful idea.
Okay, so we've got this popular, free, academic tool that's spreading all on its own. But what happened next is just a classic case of the right people meeting at exactly the right time. A moment that would completely change MATLAB's entire trajectory.
So in the early 80s, Moeller meets an engineer named John Little, and Little immediately saw the huge commercial potential here. So together, they took that original Fortran code, completely rewrote the whole thing in the more modern C language, founded the company MathWorks, and in 1984, they released the first commercial version. Just like that, the hobby had become a business.
And just look at the scale of this transformation. I mean, it's night and day. It went from a simple, free calculator with 71 functions to a full-blown commercial programming platform with thousands of them. This wasn't just an update, it was a complete reinvention of what MATLAB could be, and it was all powered by a modern language, like C.
That commercial leap basically set the stage for the next 4 decades of incredible development. So, what does that professor's little hobby become today? Let's take a look under the hood of this modern powerhouse.
At its heart, modern MATLAB is really built on 3 main pillars: super advanced mathematics, incredibly powerful graphics and data visualization, and a complete programming environment that ties it all together.
So what this means is it's not just for solving equations anymore. You can analyze massive data sets, you can develop really complex algorithms, you can build full desktop and web applications, and you can even scale your work across GPUs and cloud clusters. Oh, and it's designed to play nice with other big languages like Python and C++, which makes it incredibly versatile. But here's the beautiful part. It has never lost that initial focus on simplicity. The language is designed to let you express math in a way that just feels natural. Just look at this code. In only 3 lines, you can define a whole range of values, calculate the sign for every single one of them, and then plot the result. It's clean, it's readable, and it is unbelievably powerful. And all of that power is now being applied in some of the most advanced fields you can think of. We're talking about developing AI models, processing images for computer vision, designing the brains for robots and autonomous cars, and even predicting when huge industrial machines are about to fail.
And it doesn't stop there. It's used to design the 5G and Wi-Fi systems that we all use every single day, to analyze complex signals, develop sophisticated radar systems, and even automatically convert algorithms into code that can run directly on teeny tiny embedded processors. The reach is just immense.
So, we've seen the journey, right? From a professor's hobby to a global tech platform. But what does that all really add up to? What's the real-world impact of MATLAB today? Let's start with the people. As of 2020, there are over 4 million users around the world. I mean, think about that for a second.
That is a massive global community of engineers and scientists all speaking the same technical language.
And it all starts with education, right? It's used in over 5,000 universities across the globe. That means generation after generation of new engineers and scientists are learning to think and solve problems using this exact tool.
Ultimately, I think MATLAB's greatest legacy is that it serves as this incredibly powerful bridge. It lets a scientist with a complex theoretical model quickly test their idea, and it gives an engineer the tools that turn that very same idea into a real-world working system.
Which of course leaves us with a final, pretty big question. From a simple calculator to a full-on AI development platform, MATLAB has constantly evolved. So as science and engineering become even more dependent on computation, what challenges will it help us solve next? What does the future hold for the Matrix Laboratory?